Happy Friday, everyone! Thanks for joining us for another Planetarium live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And I'm so happy to have you joining us. For those of you who are just tuning in for the first time, welcome. We're going to be talking a little bit about some space science, and specifically, since it is Friday, we're going to be answering your questions as they come in. So if you're watching on the Union Station Facebook page or the Science City Facebook page or the Planetarium Facebook page, hopefully we'll catch all those questions as they come in. And if you're joining us for another live stream you've watched before, thanks for coming back. And definitely a big thank you to all of our Union Station members who continue to support all the programs that myself and our other Science City educators are doing while we're all at home for this time. Once again, today's live stream will be a question and answer live stream, a Fan Friday, if you will. Hopefully we've got some folks tuning in who have some good spacey questions. So feel free to put those in the comments, and I'll do my best to catch all those as they come in. We do have 3 streams going on, so I might be switching between them. So just be patient if I don't get your question right away. We'll do our best to get to all of them. I do have a couple questions that folks asked during the last live stream on Wednesday, so we're going to hit those first. And then just a little reminder what our schedule looks like right now. We're streaming on Mondays, Wednesdays, and Fridays at 6 p.m. And on Mondays, we're doing a What's Up live stream where I'm going to be showing you what's going to be in your night sky for the week. That'll be a standard star tour with checking out different stars and constellations and planets. On Wednesdays, we're going to do a deep dive live stream, and we've got a couple exciting topics coming up all about that, and I'll announce those at the end of this stream, so be sure to stick around to find out what we're going to be looking at next week. And then on Fridays, we're going to be doing fan questions so we can kind of gather them all together and answer those questions, since sometimes we'll answer questions during the earlier live streams during the week, but sometimes we don't have time, so that's why we're kind of dedicating Fridays to questions and answers. So without further ado, let's jump right in. Once again, I'm going to answer some questions we got last time. Our Wednesday live stream was all about stellar evolution, the evolution, lifespans of stars, how they are born, how they die, and different ways that they die, like supernovas and black holes. And if you haven't seen that, you can watch all of our live streams recorded on the Union Station Facebook page. Just check those out, and you can rewatch them anytime. So we've got a bunch of awesome live streams that we've done so far. So everything from a solar system tour to our star tours, if you missed those. But anyway, I'm rambling. Let's jump in and let's answer some questions. So we were talking about stellar death and how stars die last time, but we did get a question from Kelly asking if planets die, and that's a great question. And it's a question that kind of has interesting answers and maybe different definitions for what does it even mean when a planet dies. For example, let's go back to Space Engine. This is a program we've been using that you can buy for yourself at home. We're not affiliated with them, so this isn't a sponsorship or anything. Oop, I realize I'm invisible here. This is just Space Engine is a program where we can simulate the universe, which, no big deal. It's just the entire universe. But let's go ahead and go to a planet that's going to help me talk about if planets die or not. Now, you could think of planets dying in a couple different ways. One way we could think of a planet dying is if it doesn't have any more life. So now Mars, the red planet, we don't know if it ever had life or still does today. But we do know that about 1 billion years ago, Mars was covered in oceans of liquid water. But over billions of years, well, millions and millions of years, all that water has left the surface of Mars. And right now Mars is barren. It does not have any oceans of water. There are very small trace amounts of water in the soil of Mars. So, we could consider a planet dying as it losing its ability to support life. But again, we're not totally sure because Mars could be supporting some sort of microscopic life. There is an atmosphere on Mars. It's mostly carbon dioxide, but there are organisms that live in much worse conditions on Earth. So we're still keeping an eye out. The Curiosity space rover is roving around on Mars. In fact, I've got a little a visual aid to show you. Let's see here. All right. so I've got the Curiosity rover right here. This is a Lego model. You can actually buy these models, I guess, but I just put this together myself. There are instructions online, but this is the most recent robot we sent to Mars. Its name is Curiosity. Its official sciencey name is the Mars Science Laboratory. But we sent this robot back in the summer of 2012, and it's been searching for signs of water in the soil of Mars. It has a lot of different instruments at the end of this Mars, or at the end of this arm, that's able to take samples of the soil on Mars and chemically analyze it. So the Curiosity rover is giving us a better picture for if Mars is truly dead or not. Now, the other way we can answer that question is just planetary annihilation, if the planet is totally destroyed or rendered uninhabitable by other forces. And I mentioned that our sun will keep burning for about 4 billion more years before it will turn into a red giant. And at that point, it will expand to envelop the orbit of Earth. But actually, what I didn't mention last time is that the sun is very slowly and slightly getting hotter as time goes on. And in about 700 million years, the sun will have increased its luminosity and heat output that to a point where it will have rendered the Earth uninhabitable, even though it won't have absorbed the Earth. So, you know, something else to look forward to. So let's jump onwards. Jessica asked, or just mentioned that they would love to make a spectroscope at home. A spectroscope we talked about last time as an instrument that you can observe the chemical properties of different elements that emit light. And there are some instructions. I'll work on trying to get some form of Instructable up on the Facebook pages so you can have instructions to build those at home. It does require a diffraction grating, but that's something you can buy for pretty cheaply on Amazon. So spectroscope, that's on the list. Emily last time asked what type of imaging was used to capture. So again, this program we're using is called Space Engine, and it is just a scale simulation of our universe. And then we had a question from Cassandra. How long do humans have before we need to relocate? And so like I said, in about 700 million years, the sun will have changed its heat enough that the Earth will not be habitable by life as we know it. But you know, life evolves pretty rapidly, and who really knows what humans will be like in 700 million years? So right now we are working on getting to a point where we can send humans to Mars to explore, and hopefully a lot of people would like to start to settle Mars. And Mars is far enough away that it won't be as affected by those changes from the sun. So Mars seems like a pretty good candidate for a place that we might want to sort of move and have a sort of a second place where humans live. All right, so let's jump over to our comment section. I'm gonna adjust my camera a little bit here. Whoa. Go. Okay. So let's check the comments. I'm looking at the Union Station stream, and remember we are live streaming on the Science City Facebook page and the Planetarium Facebook page. If you haven't liked and subscribed to both Science City and the Arvin Gottlieb Planetarium, be sure to do that, and because we post special stuff on there that we don't always post on the Union Station page. Got a couple people saying hi. Hello from Lawrence. Thanks for joining us, Patricia. Sean is saying hello from Japan. Wow, awesome. As well as Chiho, if I'm saying that right. We've got someone from Waldo. Stephen, how's it going? Thanks for joining us. All right, let's see. We've got a question. Oh, yes, from Elizabeth asking if I could talk about the Lyrid meteor shower. Absolutely. Let me just make sure I've got all the correct and up-to-date information about that. So the Lyrid meteor shower is a meteor shower that is coming up soon. It happens around April. And let's switch actually to a different program. I'm going to switch over to Stellarium. Now, Stellarium is a free piece of software that we use for our star tours. And it's a little bit better for just looking at constellations and sort of our earthly night sky. If you want to go out into space in 3D, that's what Space Engine is good for. So we're going to wait while Stellarium is loaded up. So let me talk a little bit about meteor showers. Now, meteor showers are something that we can predict, and they happen. There are a lot of famous meteor showers that happen yearly. And this is kind of interesting when you think about it at first. You know, How can these things be predicted, and how can we see them every year? Well, most of the common meteor showers that we know, and the famous ones, happen because the Earth is passing through a cloud of debris that was left over by either a comet or an asteroid passing by. And because the Earth orbits in sort of a standard path as it goes around the sun, we know that it will pass through these clouds at regular intervals once every year. And so that's how we have these sort of seasonal or yearly meteor showers that we can measure. So the Lyrid meteor showers will be appearing from the constellation Lyra. Now this is, let's go ahead and fast forward here. Now that constellation is going to be rising a little bit later in the evening. So we're going to want to fast forward a little bit more and look towards the east. Lyra is a part of the summer triangle. Now it is springtime, so this asterism is going to be rising later in the evening, but we will be able to see it right here. So Vega is the brightest star in Lyra. It's the 5th brightest star in the night sky. And then the constellation Lyra looks like a little diamond. It's meant to be a harp here. So constellations are named, or sorry, meteor showers are named based on the constellations that they appear to emanate from. So that means that when the Lyrid meteor shower peaks, which this year will be around April 22nd or so, about next week, about 5 or 6 days, you'll see it emanating from this constellation. So that means you're going to have to stay up pretty late, around midnight, and the meteors will appear to be coming from this constellation. So they'll be coming from here, but they might be shooting in all sorts of different directions. As far as how radiant this meteor shower is, that really depends on the year, and I'm not sure what they're predicting for this year. Some meteor showers are more visible than others, and some are less so. But depending on the sky conditions, of course, and whether it's cloudy or not, you might be able to catch some meteors emanating from that region. All right, let's jump back over to our comments, see what other questions we're getting. Right. Okay, yep, we posted a little link to Space Engine. You can check that software out. Well, okay, got a question from Clara. If the sun was gone, would we orbit Mars? Ooh, that's kind of a fun question, and a question that we can use some other cool software to find out. So this third piece of software I'm going to pop up is another one you can buy at home if you'd like. Again, we're not sponsored or affiliated by them, but this is just a fun thing I like to use. It's called Universe Sandbox, and this software is more about it's like a sandbox. It's kind of playing with different things in space and using simulations of gravity to see what would happen in different scenarios. And I've never thought about this question, but let's find out right now what would actually happen if the sun disappeared. That's a really fun question, and thanks to technology, we can find out. So we've loaded up a simulation of our solar system here. And this is including the major planets, minor planets like Pluto, as well as quite a few asteroids in the asteroid belt. And what we can do is we can pause time here and we can make changes to our solar system. So let's imagine the sun disappeared. So I'm going to open up the sun here and let's delete this object. Ooh, what power. We're going to delete the sun. All right, and now what we're going to do is we are going to see what happens. If I press play here, and let's slow down time a little bit, we can see that suddenly all the orbits in our solar system have become a bit messed up. No longer is there a massive object tying our solar system together. All the planets have just jutted off from a sort of a vector from their orbital path, perpendicular to their original orbit, and have just started to fly out into space. Now, one thing that this does not simulate is gravitational waves. Now, this is kind of crazy when you think about it. So light is the fastest thing in our universe, okay? It takes light 8 minutes to travel from the sun to the Earth. But gravity also sort of obeys the same timeline. And so if the sun disappeared, it would actually, oddly enough, take 8 minutes for the Earth's gravitational path to change. I mean, it's kind of crazy to think about, but gravity propagates at the speed of light. And this is just, we're not going to get too deeply into this, but it's just kind of a crazy thing to think about, that the Earth would not immediately be affected by the sun disappearing. We wouldn't see it for 8 minutes because the light from it is still traveling from the sun, and the Earth's path would actually not change until 8 minutes, until those gravitational waves reached us, which is just a really crazy fact that kind of blows my mind. So as you can see, Mars is so far away from Earth, Clara, that unfortunately Mars's gravitational field would not be affected by ours. If Mars and Earth were close together, what would more likely happen is that Mars would orbit the Earth because Mars is less massive than the Earth. So the Earth would exert more of a gravitational pull on Mars. So, all right, continuing on. Let me go ahead and check our other streams. Let me check the Planetarium stream, see if we've got any questions on this one. All right, Olivia wants to know what planets and moons could support life. That's a great question. Let's go back to Space Engine here. Give me 1 second as we're loading it up. So we know, and there are a lot of answers to this question. We are starting to find planets in other solar systems outside of our own, but they're so far away that we can't really learn a lot about them. We can see how far away from their stars they are, and we can see how hot their stars are and how big these planets are. We can start to make inferences and predictions about, well, this planet seems like it's around the same area that our planet is relative to the sun. We call this a Goldilocks zone, where that planet is not too close but not too far away from its star. So it seems like it could be in a good spot to support life, but they're so far away that we really can't capture much more information about them. So it's hard to truly predict whether or not those planets could support life. But the cool thing is that here in our solar system, there are some places that have conditions that could support life. And as far as planets go, Mars is, again, not a great place to support life right now. Its atmosphere is very thin and mostly carbon dioxide, and there's not a lot of water on Mars right now. But there are places that have a lot more water. They're not planets, though. They're moons. Let's go over to a moon called Enceladus. This moon is around Saturn. If we fly over to Saturn here, we can see Saturn and its beautiful rings, and we can see Enceladus is one of the major moons of Saturn orbiting close to it. That means it was formed during the formation of our solar system with Saturn. The moons that are farther out orbit at much more steep angles. In fact, we can't see them. Let's turn them on. We call them dwarf moons. So you can see Saturn has quite a few moons, 82 known moons, the most known moons in our solar system. But Enceladus is one of the major moons here. And if we zoom in on it, I'm going to turn those dwarf moons off. All right. Back to Enceladus. Enceladus is an icy moon. It is one of the most reflective moons in our solar system. In fact, I think by many metrics it is the brightest and most reflective moon because it's covered in a thick sheet of water ice. Now, this water ice covers the entire moon. It looks kind of like a big snowball. There was a probe named Cassini that we sent to Saturn a few years ago, and it orbited Saturn for about a decade. It recently has, its mission ended when it ran out of fuel, and it crashed into Saturn on purpose. But while its mission was going on, it flew around all the moons of Saturn, and it took pictures of them. And it took pictures of Enceladus as it flew by. And when it did that, it noticed something kind of cool. Let me get a picture for you. All right, I'm gonna make sure that I'm getting a real picture because there's some really cool. Let's see. Cassini flew near Enceladus, and it saw some geysers coming out of the poles of Enceladus. Here we go. All right, this is an image from NASA. We're doing this live, folks. All right, here we go. So this picture was taken of Enceladus by Cassini, and it noticed these geysers coming out of the poles. Now, after a couple more orbits of the spacecraft Cassini, NASA sent Cassini to fly even closer through those geysers, and it actually passed kind of right through them. And when it did that, it actually detected trace amounts of liquid water. And we also know that Enceladus is close enough to Saturn to be affected gravitationally by Saturn, which means its core is likely volcanically active, which means that there is an ocean of liquid water below the surface of Enceladus, below those sheets of ice, that is likely warm. So we know that there's an ocean of warm liquid water somewhere else in our solar system. So of all the places in our solar system, Enceladus seems like one of the most likely places to support life. So someday we may send a probe there to land on Enceladus and maybe even drill through that ice. But who knows? There could be life somewhere close by. All right, so that answers your question, Olivia. Let's continue on. All right, David's asking what my opinion is on Pluto being downgraded to a dwarf planet. And that's a great question. Let's take a look at everyone's favorite dwarf planet, Pluto. Oh, Pluto. Pluto's great. We like Pluto a lot. Now, Pluto was discovered in the early 1900s. And since its discovery, there have been a lot of other objects like Pluto, similar to its Pluto's size and in similar orbits as Pluto, that it got to the point basically where in the early 2000s there was a list of almost 100 objects that were candidates to be considered planets because they were sort of just as good as Pluto. And so astronomers got to thinking that, you know, maybe we need to redefine what it means to be a planet, because Pluto is pretty different than the other planets. Let's go ahead and turn the orbits of Pluto on. There we go. So if we look at Pluto's orbit, it looks pretty different than the other planets. We'll see it here in sort of teal, and bright green are the regular planets. Now, the 8 regular planets orbit very close together in this flat disk. We call that disk the ecliptic. But as you can see, Pluto orbits at a very different angle, along with the other dwarf planets like it. So astronomers got to thinking, and they decided to redefine what it meant to be a planet. And to be considered a planet, you have to follow 3 rules. Number 1, you have to orbit around the sun. I mean, that's kind of a no-brainer. The moon is not a planet because it goes around the Earth, but the Earth is a planet because it goes around the sun, all right? Well, Pluto clearly goes around the sun, so it checks that box, so to speak. The second rule is that you have to be large enough that gravity has formed your mass into a sphere. There are a lot of smaller rocky objects like comets that are orbiting the sun, but they don't just feel like planets, right? They're small and rocky, and we like to think of planets as nice and round, right? Well, we didn't know what Pluto really looked like until about 2015 when the spacecraft named New Horizons flew by Pluto. And when it did, it took close-up pictures of Pluto, and we did see that once and for all, we were sure that Pluto is nice and round. This is the best imagery we have of Pluto. New Horizons was flying so quickly, it could really only take high-resolution photos of one side of Pluto, so the other side's kind of blurry, but we know that it is a nice round shape. So it checks the second box. Now the third box, the third rule you have to follow to be a planet, is the rule that Pluto breaks. To be a planet, you have to have cleared your orbital path of other objects and debris. Now Pluto is so small that it has a system of moons that affects it gravitationally, and it actually orbits its own moons. So this red circle here is the orbital path of Pluto. So Pluto, or its moon Charon, does not go around Pluto in a perfect circle. Pluto is actually pulled by Charon as well. And if maybe I can show you what that looks like. If I track this point, this is called the barycenter, which is the center of the orbital interaction between these two. There we go. We can see it right here. We can see that Pluto actually orbits its own moon. So Pluto has not cleared its path of every other object. But Pluto is not considered a planet. It is a dwarf planet, the biggest dwarf planet, and it's among good company with other cool dwarf planets like Ceres, which is in the asteroid belt. So don't worry, Pluto's still out there. Now, a fun fact I like to talk about is that since Pluto was discovered and since it was demoted as a planet in 2006, it actually never made one full orbit around the sun. So Pluto never got to celebrate one birthday as an actual planet. So everybody pour one out for Pluto. All right, let's check on the Science City stream, see if we've got any questions over here. Again, thank you all for tuning in, wherever you're tuning in. Okay, looks like we got a question from David. What got me started into astronomy, and what was my learning process growing up from childhood till now? Telescopes, clubs, families like that, that's a great question. So I've been interested in astronomy for most of my life. When I was growing up, my parents made sure that I got to learn all about science in a lot of different ways, astronomy and ecology and math and all those things. And I ended up becoming pretty passionate about astronomy, but just sort of as a hobby. And it was around high school and college that I started learning more about it and diving in deeply, and got my own telescope and started to get involved with astronomy clubs there and started to do astronomy programs myself. So I've been interested in space science and astronomy for a long time. And as far as my professional background, I've worked in informal education, so a museum experiences in a lot of different ways, working on exhibit design and maintenance, all the way to program delivery and education. And so combining those two things is kind of how I ended up at the planetarium. So it was a combination of just being passionate about something and learning about it, and finding a way that can cross over into my career path. And there's a lot of technical and computer science stuff that got me into this field too, and managing these live streams and switching between green screen scenes and software and stuff like that definitely helps a lot as well. So hopefully that answers your question. There are a lot of other great resources here in Kansas City specifically. The Astronomical Society of Kansas City is an awesome group of people who I've learned a lot from. They've helped us in the planetarium before, so special shout out to them for sure. And they are a really great resource, and they're all super nice and would love to help you learn about telescopes and astronomy as well. And of course, you can come to the planetarium and check out one of my star tours once we open back up. Okay, we've got a question from Hani, it looks like, or Hani. How was the moon created? Oh no, this is from Eleanor and Miriam. Eleanor and Miriam, how was the moon created? That's a great question, and a question that we don't know the real answer to unless we got a time machine, of course. Let's go over to the moon. While we're flying to the moon, let's see if I can find something that we can... Ooh, you know what? I think we can actually use Universe Sandbox to learn about this. Now, there are a lot of different theories for how the moon was created. And one of the main theories right now is that during the formation of our solar system, about 1 billion years into the Earth's life, an object about the size of Mars crashed into the Earth. We even have a name for it. They call it Theia. And when that object crashed into the Earth, it kind of scraped off a chunk of the Earth and made it sort of float around. And over time, gravity kind of pulled that chunk of Earth that kind of got sliced off and turned it into the moon. And I think there is a simulation built into the software that maybe will show us that. I hope so. Oh, let's see. Let me double check. Yeah, thanks for your patience, folks. Let's see. Well, okay, looks like we may not have an example of this. If I search for it. Well, I'll continue to work on that, and maybe at a future live stream, I will be able to show you that. You know what? Let's try this. Let's see what happens. There is a simulation of Mars crashing into the Earth. Obviously, that would be a very bad day for all of us. But as you can see, when Mars crashed into the Earth, a bunch of debris kind of got shot out into space. And that debris is floating around. And if we speed up time enough, you'll see that there's going to be some debris kind of floating around, orbiting the Earth. And over a very, very long time, billions and billions of years, this debris would eventually kind of coalesce from gravity to form the moon. And that's the main theory. And this is not just a crazy idea. This is based on when the Apollo astronauts came back from the moon with moon samples. We studied the material found on the moon, and we found that it had similar properties to the material on Earth. So we think the moon is very geologically similar to the Earth. So that is a big theory for one of the most accepted theories for how the moon was formed. So hopefully that answers that question. Let's see where we were with our comments. Let me check the time too. Ooh, we've gone for about 30 minutes. Let's see. Ooh, I think I might have. Right, we were looking at Science City. And all right, yeah, okay. So David's asking what telescopes I currently own. I'm going to talk about telescopes a little bit later, so stay tuned for that. What is in the center of other planets? Kristen asks. That's a good question. let's see if I can find a good graphic that would show us. It depends on what type of planet we're talking about. The rocky planets, like Earth, many of them have molten centers. So the Earth's core is a core of molten iron, which is constantly being moved around. That's what creates the the magnetic field of Earth. Mars has a much weaker core, and we don't know if it's as geologically active as the Earth's. We don't think so, at least. And there's a probe that we sent to Mars recently that's studying seismic activity inside of Mars to figure out whether or not Mars has a volcanically active core. We think that it probably doesn't because Mars does have a very weak magnetic field. So it's unlikely that it does. The gas giant planets, we don't know what their cores are made out of. There are some spacecraft like Juno, which is orbiting Mars right now, Jupiter right now, is trying to figure out what could be through the clouds of Jupiter and the other gas giant planets. But there are a lot of different theories, and scientists don't completely agree on whether they have a solid core or whether it's just a gaseous core. So we're still trying to figure that out. And again, there are some planets whose cores are made up of oceans of water, like Enceladus, or some moons, like Enceladus, as well as Europa, which is one of the moons of Jupiter. So I couldn't find a great graphic for that, unfortunately. But let's continue onwards here. Right. What galaxies are nearest to the Milky Way? That's a great question that Space Engine can answer for us. Let's load Space Engine back up. And you might be surprised by this, but the Milky Way galaxy, this is, by the way, a question from Eleanor Miriam again. Great question. What galaxies are nearest to the Milky Way? There are quite a few, and there are actually some that are super close that those of us living in the northern hemisphere are kind of unlucky because we can't see them, but people living in the southern hemisphere can actually see two galaxies that are orbiting the Milky Way galaxy. That's right, there are entire galaxies that are orbiting our galaxy, and they're very bright, and you can see them if you're in the southern hemisphere. They are named the Small and Large Magellanic Clouds, named after Magellan, an explorer that explored the southern hemisphere. So let's go back to Space Engine here. Press the wrong button. All right, there we go. Well, let's zoom out and out and out and out and out and out. Ooh, I want to show you something kind of cool, actually. Oops. Let's fly back to where we were. So we can connect the constellations here. And let me turn planets off. Now, these lines are connecting stars. One thing I've talked about before is that when we looked at the celestial sphere here, this thing is called an armillary sphere. We've used this before to talk about the zodiac, but the stars are not laid out in the same distance from us like this globe shows us. Certain stars are farther away than others, and we can actually see in Space Engine how that is when we zoom out. And as we zoom out, we'll actually start to see let's keep zooming. Here we go. So we're going to see the constellations starting to change shape here. And we can see that our night sky actually is sort of 3D. This is a pretty cool view. We see this view in the planetarium during our star tours as well. As we zoom out, we'll start to notice that our entire night sky and all the famous constellations are actually just a very tiny portion of the entire Milky Way galaxy. As I said, there are two galaxies orbiting our galaxy. They are named the Small and Large Magellanic Clouds. And we can see them right over here. Got the large one there, the small one. Now, they're pretty far away. They're about 582,000 light years away from us, but they are actually orbiting the Milky Way. And you can see them in the southern hemisphere. They appear as big clouds of light in the night sky there. So those are the closest galaxies to us. Now, there are other small galaxies that are close by, but sort of the most famous spiral galaxy that's close to us is the Andromeda galaxy. And that is right over there. So this is our sort of local group of galaxies that sort of live close to us here. And the Andromeda galaxy is kind of like the the largest galaxy that's close. So it's about twice as big as the Milky Way galaxy. It has about 1 trillion stars. And there it is, Andromeda. Karen's asking, what is the Milky Way? Well, the Milky Way is our galaxy. It's our sort of star neighborhood. It is how the stars in our sort of local group are organized. It contains about 500 billion stars, and all these stars orbit around a central point, which is a supermassive black hole. So this is just our little neighborhood of space, basically. Neighborhood of the universe. David's asking to see the Southern Cross. Let's see, what's the best way to do that? Let's try to stick in Space Engine here. Let's go back to the Earth. Earth. All right, so we can see the constellations here once again. And the Southern Cross is going to be in the southern hemisphere. I can actually turn the planets off. There it is, right over here. I don't know if you can see my mouse. Here, let's try this. Oh, it's right there. All right, it's Friday, folks. That's the Southern Cross. Now, one thing people have asked is there a South Star? And there is not a star bright enough to be visible to the naked eye in the South Pole, but if you use the Southern Cross, as well as 2 stars next to it right here, we call them pointer stars, you can kind of triangulate where the South Pole is. All right. Kristen asks, how are planets created if there were only stars and meteors to begin with? So we talked a little bit about how solar systems were created in our last stream. So if you want a longer description of that, be sure to check out that recording, which you can find on the Union Station Facebook page. But just to be very brief, basically after a star is formed, there's a lot of other debris left over floating around. Gravity pulls that debris together. That's how stars form. There's gas and dust and rocks floating around in space and nebulas, and gravity very slowly pulls it together, kind of like making a big clump of Play-Doh, and it keeps pulling stuff together, and eventually that forms stars. And sometimes there's a little bit of cloudy debris floating around farther away from the star, and instead of getting pulled into that star, it gets pulled into itself to form planets. So it's all thanks to gravity, basically. That's where planets come from. Kirsten's asking, are there going to be more live sessions like this? That's right. On Mondays, Wednesdays, and Fridays, again, we are going to be streaming live at 6 p.m. Mondays will be our Star Tour stream. Wednesdays will be our Deep Dive topic stream. And Friday will be this Q&A stream like we're doing now. Now, we are running out of time. We've got a lot of awesome questions. This is so great. I'm so glad that this is, you guys are all chiming in here. And there are so many great questions being asked. Let's see. Oh, Katie asks, how many years does it take for Pluto to orbit the sun? That's a great question that I don't know exactly off the top of my head. Hey, let's find out. Okay, Google, how many years does it take for Pluto to orbit the sun? 248 years. There you go. 248 Earth years. Hey, if you've got a smart speaker at home, you can ask it, and it'll answer a lot of simple questions like that. Eric's asking, are there rare elements that could be mined on the moon? And there definitely are. There are a lot of elements on the moon that I don't know exactly off the top of my head, but we can do some research to find out, see what kind of useful elements. So there's actually gold on the moon, as well as platinum, and there are other rare elements that could be used for electronics. There's magnesium and silicon and iron and calcium, a lot of great stuff there. And one of the cool things is that there is actually frozen water on the moon. We have sent probes, we've sent missiles into the moon to create big clouds of debris that satellites have taken pictures of and used spectroscopy to find the compositions of. And when we did that, we actually discovered that there is frozen water in some of the soil on the moon. So there's a lot of great stuff we could find on the moon. And that's one of the reasons why some scientists, as well as business people and entrepreneurs, want to go to the moon and want to explore asteroids, because there are insane amounts of elements that are pretty rare on Earth that are a lot less rare in asteroids and things like that. So a lot of people think that asteroids and lunar mining might be a really great business opportunity. But first, we got to get there, and there are a lot of missions that are looking to get back to the moon sometime soon. Okay, we've got just time for a couple more questions, and we've got so many great ones. We're going to write down all the questions we missed, so I do apologize if we missed your question, but don't worry, we will try to answer those questions on a future stream, and I might go a little bit long on this one just because it's Friday, and I don't know about you guys, but I've not got much else to do tonight, so let's see what other questions. Okay, Southern Cross, we already saw that. Eric asks what projects and missions are underway to find life. So I talked about the Curiosity rover that is looking for life in the soil of Mars. There are some future missions that are still in the development phase, some aquatic submarines that we would like to send to moons like Europa and Enceladus. And right now those are in the design and concept phases. But those missions may happen sometime in the next 10 or so years. There are, of course, many more missions to Mars planned. In fact, there is a rover just like Curiosity that actually just got its name. Its name is Perseverance, and right now they're putting the finishing touches on building it, and that has been scheduled to launch towards Mars this year. The schedule may be affected by other global events happening right now, but hopefully this year or early next year, that rover will be sent to Mars, and its mission will be similar to Curiosity's mission. Let me head over to the Union Station page to check out. Got a lot of questions here. Thanks for sticking around, folks. And I'm just going to keep answering these questions until I get the sort of hook from my moderator, if that sounds all right. Also, there's something weird going on with my face, but we're not going to worry about it. Again, we're doing this live. Let's see. Continuing on here, David's asking about telescopes. So let me just jump in real quick about that. One of the topics I'm going to cover on a future Wednesday stream is I'm going to do a tutorial on telescopes. I've got a telescope here that I'm going to adjust my camera setup, and I will teach you guys how to set up and use a telescope. Now, there are a lot of different types of telescopes. The telescope I'll be using to demo is a reflecting telescope with an equatorial mount. So if you have one of those sitting around at home in your attic gathering dust, be sure to get that out, dust it off, and follow along during our future live stream. And that may not be next Wednesday, but that will be coming up really soon. So there might be some time if you'd like to order one, but shipping times are a little dicey right now. So just keep that in mind. But again, we're going to be doing a live demo about telescopes in the near future. So stay tuned for that. All right. Continue on. Words. All right. Bunch of great questions. Michael's asking if someone wanted to buy a good telescope, what should they look for? So again, just to elaborate on what I was talking about earlier, we will be doing a stream about telescopes, and just a little primer for that. There are a lot of great telescope companies, and I won't endorse just one of them, but there are a lot of famous ones. Companies like Celestron and Orion are great options for starter telescopes. The aspects to look for in a telescope is the aperture, so sort of the diameter of the tube. Basically, the larger the diameter, the more light that telescope will capture, and the better you'll be able to see objects like planets and nebulas. I recommend anywhere from a 4 to 6 inch wide telescope tube to start out with. And as far as mounts go, there are a lot of different types of mounts. There's an altitude and azimuth mount that is sort of like a camera tripod where you just go left, right, up, and down. Those aren't great astronomy tools, though, because they can't track objects in the sky. An equatorial mount is what I would recommend for that. And I won't recommend a specific telescope, but again, there are a lot of great options you can find online, and we'll dive deeper into how to actually use those telescopes on that future stream. Let's see. What was the most recent and interesting space discovery? Lauren asks. That's a great question. I really like the discoveries about Betelgeuse, the star that had been dimming for a couple months but started to get brighter again. Just learning about that star, which we expect to go supernova in the near future, and learning more about what red supergiants are like and how they aren't really spherical in shape. They're more like big, cloudy, hot masses of gas. That's a fun discovery. I think my favorite thing of the past year or so was that picture of a black hole that was taken by scientists. It was the first time we ever imaged a black hole, and that black hole was inside the galaxy M87. And let me just pop up that picture for you to see. So this is an actual image of a black hole. This is a picture of a black hole. I mean, how crazy is that? This is the event horizon. This, the point of no return for this black hole is 4 times the width of Pluto's orbit. So this is gigantic. It's, you could think of it as 4 times as wide as our solar system. That's just the event horizon of the black hole. So this thing is really big. But this is a photo of this black hole. This ring out around it is called an accretion disk. And it's a ring of charged particles that are accelerating close to the speed of light, which is why they are so bright and energetic. That, I think, might be my personal favorite space discovery, just that photograph of a black hole. I mean, how crazy is that? We took a photograph of a black hole. I just think that's really cool. All right, continuing on here. Lauren's 8-year-old is asking, has anyone ever seen an alien? And not that we can confirm. We have not found extraterrestrial life yet. There's some weird examples of life here on Earth. Life that can live in extreme conditions, extremely hot conditions at the bottom of the ocean, and life that can even live in the vacuum of space. If you want to learn more about crazy life on Earth, look up a tardigrade. Those are kind of fun biology to learn about. Right. Let's see. Ollie's asking what would happen if the gravitational pull decreased. So I'll elaborate on that question and answer the question, what would it be like to be in a place that had less of a gravitational pull than the Earth? Well, we can actually find out about that by asking astronauts who have been to the International Space Station. The International Space Station is accelerating so quickly that it is orbiting the Earth, and it is continually falling down towards Earth, but never falling all the way. So it's in free fall, and when an astronaut goes to the International Space Station, they experience weightlessness. It's not zero gravity. We call it microgravity, but what they experience is weightlessness. Their feeling they have is no gravity. And the human body is affected by that in a lot of ways. Our body is used to gravity pulling, for example, the blood in our bloodstreams downwards towards the ground. But when you're in space, your body has to readjust because blood easily floats up to your head. And so a lot of astronauts will start to feel lightheaded at the beginning because blood is rushing up there. And their body readjusts to that. As well as also without gravity, your bones and muscle health, you have to work extra hard to keep that strong. So astronauts are required to exercise all the time on the International Space Station. And they actually have straps that pull them down to treadmills so they can sort of run in microgravity. So the human body is affected in a lot of ways, and there are ways that we're still understanding. There's an astronaut named Scott Kelly who is a twin. He went to the International Space Station and lived there for a year, and his brother lived on Earth. And he's part of a very long study where they're studying both of them and learning about how the human body changes when you're in space versus when you're not in space. That's a great question, Ollie. All right. So we are approaching, I don't want to go over an hour, so we're just going to answer just a couple more questions. And it looks like our questions are kind of petering out. Susan's asking, how do black holes form? And I'll answer that question by directing you to the recording of our live stream on Wednesday. You can find that on all of our Facebook pages and rewatch that. We talked all about how stars are born, how they die, and how black holes are formed. So check that out if you'd like to learn more about that. Jonathan's asking, how do we know planets and moons exist within the Andromeda Galaxy? And the answer is that we don't really know. But science is all about making educated inferences based on what we know. And we know that the Andromeda Galaxy is organized similarly to the Milky Way galaxy. We know how stars form. We can observe that in our own galaxy. So we can infer that discoveries we make about the Milky Way are going to be similar in the Andromeda Galaxy. And we have discovered that about half of the stars in our galaxy have planets orbiting them. And those numbers change over time as we learn more about stars and planet formation. But we know that there are a lot of planets in our galaxy, so it stands to reason that there are planets in other galaxies. All right, I'm going to check our other streams to see what other questions we might have gotten. Ethan wants to know what the biggest planet that is not in our solar system that we know of. That's a great question. So we call planets outside of our solar system exoplanets. And the largest exoplanet we know of, it looks like, is a planet. There we go. A planet, let's see, the list of the largest exoplanets that we have found. The largest one in the NASA Exoplanet Archive is a planet with the very interesting name HD 100546b. Now this is a simulation of our universe, and it is pretty up to date, but if this one was discovered recently, it may not be here. There are a lot of exoplanets in the Space Engine database. Oh, hey, look at that. It's there. Let's fly over to it. Oh, that looks like a star. Let's see. Oh, no, we want to find the planet. Let's, Hang on a second, folks. Oh, we're still flying to it. That's a star, but there should be a planet somewhere around here. This planet, though, is appears to be see about 7 times the size of Jupiter. Now it looks like it should be in this database, but Space Engine is not wanting to show it to me. Let's. Oh. No, so can't quite find it, but that sounds like it's the largest planet that we know of. And let's let me check our Science City stream. Again, thanks for tuning in to all of our streams, folks. It's exciting that we have different sources for you to watch us from. And I hope that I've gotten as many questions as I can from all of you. Let's see. David asks if I've met an astronaut. I've met a couple astronauts, and I'm very thankful and lucky to have met them. The Planetarium, the Gottlieb Planetarium, hosted a planetarium conference in 2013 where I got to meet astronauts, and during the 2017 solar eclipse and leading up to it, I was lucky enough to get to speak with an astronaut about that eclipse. So I've met a couple, and they're all very cool. All right. Okay, and this will be the last question I answer, and I hope I've got a good answer for it. Michelle is asking, if I could discover a planet, what would I name it? Oh boy. I had a question a few weeks ago about what I would name a star, and it took me a while to think of that answer, so I'm going to do my best to think on the fly. Planets are interesting. All the planets in our solar system are named after Roman deities. Jupiter is the king of the Roman gods. It's similar to the god Zeus in Greek mythology. So it would make sense that you would name a planet after something in mythology like that, but there are a lot of moons named after things in mythology, and we're sort of running out of stuff like that. So if I would name a planet, maybe I would name it after a famous scientist or something like that. Let's see. I think I would name a planet after maybe one of my favorite astronauts. I think I would name a planet May, M-A-E, after Mae Jemison, who was an engineer and physician who was an astronaut in the late 90s. She was the first African-American woman to go to space, and just an all-around really cool person who is an advocate for science education. And you can learn more about her. You can look her up, and after she was an astronaut, she's continued advocating for space learning. So maybe I would name him after a famous explorer like that. And that just seems like a nice planet name, right? May, M-A-E. I don't know. It's short and sweet. I wouldn't get too complicated with it. Hopefully that's a good answer. And that will be the last question I answer. If you had a question that we didn't make or we didn't answer during this stream, then we'll write it down, and we'll for sure try to answer that on Monday during our next stream. Once again, right now our schedule is Mondays, Wednesdays, and Fridays at 6 p.m. I'll be streaming live from space, and Mondays will be our What's Up tour, where I'll be showing you what you can see that week in our evening skies. Wednesdays will be our deep dive show. And stay tuned. We will have a schedule for that by early next week, and so you can plan which Wednesdays we'll be diving into different topics. I've got a couple interesting topics planned and lined up, and one of those will be all about putting together your own telescope and how to use a telescope. That may not be next week. It'll take a little time to plan and prepare for that, but that will be coming up. So be sure to stay tuned, and we will keep you posted about all that. I wanted to thank you all again for tuning into this live stream. These are a ton of fun. I've really enjoyed them. And the Fridays are great because I love answering our questions, and you have so many awesome questions. So be sure to tell your friends and have them tune in as well. And be sure to like and subscribe to the Gottlieb Planetarium Facebook page, as well as Science City and Union Station. And just one last reminder to keep these experiences going. Union Station would always welcome your help, whether it's joining and becoming a member. There's a lot of great member benefits that come when we reopen. And there are other ways you can support us. If you just go to unionstation.org, you can learn more about that. And if anything, just watching these streams and asking cool space questions is a great way to show your support. And hopefully pretty soon I'll be able to see all of you under the stars at the Planetarium. For now, though, this has been Patrick Hess, your Planetarium specialist. I hope you all have a stellar weekend, and I will see you on Monday at 6 p.m. Have a great day, folks.